So let's see if we can actually have a sketch of some of these functions. So the first thing to do whenever having a look at a function, y equals e to the x minus 2 plus 3, is to identify the sort of transformations that have happened. So there's two transformations happened from our basic function. We've got the minus 2 next to the x, and we've got the plus 3 to the whole function. Now these are both translations, and we've got to remind ourselves what sort of translations. The translation right next to x is going to affect our horizontal position, our x position. The one that is to the whole function is going to affect our y position. So the yellow is going to be our horizontal translation, and by 2 units. And we've got a vertical by 3. The question then becomes, is it left, right, up or down? Now vertical translations are the easy ones. Why? Because they follow the thing. So in this case it's 3 up. So it's by 3 units up. The horizontal translation by 2 means that, remember, horizontal, you always got that minus b. Remember, it's e to the x minus b, meaning we swap the sign, meaning it is actually 2 units to the right. Okay, so if I wanted to sketch it, what do? Well, first of all, I'm just going to draw my original function. And what am I going to do? I'm going to shift it 2 units to the right and 3 units up. Now, what's that going to mean overall? Well, firstly, it's going to mean that my asymptote has moved, right? My original asymptote was at 0. 3 units up from 0 is 3. So my new asymptote is going to be starting here. The fact that it's been shifted 2 units to the right means that this point 0, 1 is actually going to be moving 1, 2 to the right, which is going to be 2, 3 up is going to be 4. So this point actually moves up here, and we can sketch in our function. And there is our function sketched. If we wanted to work out, say, the x-intercept, the y-intercept, we can still do that just by substituting in x equals 0, and we'd find it is going to be 3 plus something to do with e. Not too difficult to work out. Let's have a look at another one. Alrighty, so let's break it. Let's have a look at this one. So we've got y is equal to 1 minus e to the 0.5x. So we've got 3 edits that have been made. We've got this 1, we've got this negative sign, and we've got this 0.5. Let's deal with each of them individually. Now the 1 is just a vertical translation. It's just written in the wrong spot. We'd normally see it as plus 1 on the end, but if you move it to the front, it is still just a vertical translation by 1. Up by 1. We've got a minus. That is going to be a reflection of some sort. So this minus e to the x, well, that is a reflection. Question is it an x-axis reflection or a y-axis reflection? And in this case, it is an x-axis. Why? Because it is affecting the whole function, not just x. When x gets minused, that is a y-axis reflection. When the whole thing gets reflected, it is an x-axis reflection. Alrighty, so reflection on the x-axis, and then the third thing is we've been dilated by horizontally by a factor of 1 on 0.5, which is actually equal to 2. So a few reasons you can think about that, but 1 over 0.5 is 2, so it's actually being dilated by a factor of 2, which means stretched out in the x directions by that. So let's do these 3 transformations. So if I take my axes, my original function, let's have a think about it. So first of all, it's getting, so order of operations does actually matter here. If we do these translations in the wrong order, it is going to cause us some issues. So let's do the stretching first. So the first thing that happens is that it's going to get stretched out, which means that it's going to look something a little bit more like this. It's going to get 2 times further away. So that's the stretching been done. Then we're reflecting in the x-axis. Well, that means it's going to be looking like this, mirroring. And then finally, we're going to be vertically translating it up 1, which just means we're going to move the whole thing up 1. So select it and move it up 1. Now, because of this last bit, it means that our asymptote is going to have moved up to x equals 1. Okay, so there's an idea of what these sorts of transformations look like. We'll do one more transformation just to have a play with, and then we'll be moving on. Alrighty, so let's look at this one. So we've got 6 times e to the x, 6 times e to the x. Alrighty, so in this case, we've got 2 transformations that have happened. And the first one is this multiplication by 6, and the second one is this little negative. So the 6, well, that is just a vertical dilation by a factor of 6. And the negative is just a reflection, and this is a reflection in the y-axis. It's going to be flipped vertically. Alrighty, so we've got it. Let's just go for it. So let's take our axes, set them up nicely, draw in our original function, and now we're going to start playing with it. So in the first thing we're going to do is reflect it in the y-axis. So now instead it's going to look like this. Beautiful reflection. You have to use your imagination, I'm afraid. And the next thing is that it's getting vertically dilated. So vertically dilated means it's going to be pushed away from the x-axis. It's going to be pushed away. And so it is going to stretch. However, the asymptote is not changing in this case. Why? Because although it's getting stretched, that isn't going to change the x-axis. It isn't going to change the asymptote. So the asymptote is still going to be at 0 because it hasn't been translated up or down, but you can see that it is getting moved up, at least here. And we get this new 0.06. And you can think about it by substituting in e to the negative 0 is 1. And so you get 1 times 6. So this would be our final function here after all of the translations. A little bit stretched up and reflected in the y-axis. Alrighty, so that's a little bit on translations. I will see you in the next one. Bye-bye.